We are asked to determine the rate of change. And you say, I already know that, because the slope basically is the rate of change. They say that every picture tells a story, and so does a graph. And so today we're going to put stories to graphs, and instead of calling it slope, we're going to call it the rate of change in the graph. It will still be a ratio or a fraction that indicates the change in y values or the vertical change, and the change in x values or the horizontal change. The change in y values is called the rise, the change in x values is called the run. So let's determine the rate of change, or slope, using a table of values like this. This table is made up of x values and y values that form ordered pairs, such as -4, 1 here. So let's determine the amount of change that occurs as I go from this point -4 to this point -2. We can see that I added 2. Then if I want to go from -2 to the point 0, I also add 2. And from 0 to 2, I see that I'm adding 2. And when I go from the point 2 to 4, I am also adding 2. What this table shows us is that the amount of change is a consistent amount of change, or a constant amount of change, of +2 from point to point on the x values. Now let's measure the amount of change on the y values. Going from -1 to 0, I added 1. To get from 0 to 1, I added 1. To get from 1 to 2, I added 1. And to get from 2 to 3, I added 1. What this means is there a consistent or a constant change in the y values from point to point of 1. And this is a way of measuring the slope here, which is 1/2. However, we're going to call it the rate of change. Let's see what this looks like on a graph by plotting points. By plotting these points, you can see that we get a straight line. A straight line occurs when we have the same change or a constant slope between each point on the table. Therefore, a straight line on a graph indicates a constant rate of change, which means the slope is the same from point to point to point to point. You can also determine a constant rate of change by making calculations on a table such as this. Let's try this one. Let's determine the rate of change on the table. When I move from -4 to -2, I add 2. When I go from -2 to 0, I add 2. When I go from 0 to 4, I have added 4. And from 4 to 7, I'm adding 3. Looking at the y values, when I go from -1 to 0, I added 1. And from 0 to 3, I add 3. And from 3 to 2, I actually subtract 1. And from 2 to 2, I don't add anything. Let's set these fractions up in slope fashion with y over x. The first one sets up as 1 over 2. The next one sets up as 3 over 2. The third one sets up as -1 over 4. And the last one sets up as 0y over 3x. Please note that none of these slopes appear to be the same, so let's graph it. So what we see here is that the slope from here to here is not the same as here to here, so it's not a constant change. It changes again here, and these are the same. So this is a picture of a variable rate of change, not a constant rate of change, because it is not a straight line, and all of the slopes between the points are not the same. And now we're going to look at the pictures of 4 graphs that tell the story of an oven. In these graphs, time will be in minutes, it will be x, and temperature will be the y-axis. So let's check the amount of change on the x-axis from point to point. Here it's going to be a +1. Here it is going to be a +1 from 2 to 3. And from 3 to 4, a +1. And from 4 to 5, a +1. Y-axis, when we go from 10 to 20, it's +10. From 20 to 30, it's +10. 30 to 40, it's +10. 40 to 50, it's +10. So if we were to construct the slope from this, the y over the x is a constant change of 10 to 1. And if we were to graph these points here, we would expect to get a straight line, and we do. And that is because the rate of change is the same from point to point to point to point. So this is really the story of how fast an oven is heating up at 10 degrees per minute. That is its rate or its speed that is warming up. Let's take a look at this graph where I'm going to start to calculate the amount of change in the x values. You can see that as we go from 1 to 2, it's an increase of 1, and that is consistent or constant all the way through. So the change in the x values is plus 1. Calculating the change in the y values, they are all constant as a plus 20. So if this were your oven, what is it doing and how fast? I hope you said your oven is heating up at a rate of 20 degrees per 1 minute, which is faster than the prior graph. You can see that after 5 minutes, this was heated up to 100 degrees, which is twice as fast as the other graph. Please note that this line is steeper than its neighbor on the left, which means a faster rate of change, or speed. Make your slope calculations on this table and tell me what this oven is doing. Make your slope calculations on the table and tell me what this oven is doing. Working from the table, we see that x values have a constant rate of change of 1, and the y values have a constant rate of change of 0. So looking at y over x, we have 0 over 1, which equals a 0 slope. A 0 slope is horizontal, so it's a straight line just like this. And I hope that you see that over time, your oven is staying the same temperature, not heating, not cooling. Now look at this graph, do your calculations on the table, and tell me what this graph is doing with your oven. If your calculations are correct, you'll see that there is a constant rate of change on the x values of plus 1 and a constant rate of change of the y values of minus 10. So if we look at that as y over x, or slope, it's minus 10 to 1. What does that mean? It means going down 10 degrees for every minute. So without looking at the graph, you can tell your oven is cooling off at a constant rate of 10 degrees per minute. And when you graph this, you'll see it's a negative slope that goes in this direction as our oven is cooling off. Hope this helps.